Hi, today we are going to discuss about the semiconductors, which material conductivity lies in between insulators and conductors. That materials are called as semiconductors. Semiconductors are two types. Intrinsic semiconductors, or it will be called as a pure semiconductor. And next one is extrinsic semiconductors, or doped semiconductors. So extrinsic semiconductors further classified into two types: N-type semiconductors and P-type semiconductors. We know that the semiconductor is a fourth group element. It means that four electrons are available at the outermost orbit. When an isolated atom is there, so when four unpaired electrons are available, so at that situation it having instability. So for stability purpose, the silicon atom is ready to pair with other atom, or it is ready to form a bond with a neighboring atom. So if we are considering all silicon atoms, so all silicon atoms, they are forming a covalent bond with the neighboring atom. In this case, the electrons are sharing between the atoms. So based on this, if we see the intrinsic semiconductor, so in the diagram we are observing that this is a silicon atom and we have four unpaired electrons are there. And similarly, the neighboring atoms are also silicon atom because it is a intrinsic semiconductor, means pure semiconductor. So all silicon atoms are available, and each silicon atom is donating one electron and sharing with the neighboring atom and forming a covalent bond with the neighboring atom. So if we go for the conduction band and valency band, pure semiconductors are insulators at the absolute temperature. As the temperature increases, the electrons will absorb the energy and they excited to the higher energy state. So the conductivity of the material increases. At the absolute temperature, the electrons are bounded between the two neighboring atoms. So there will be no free electrons in the conduction band. So it will act like a bad conductor. In the valency band, we having the electrons, but these electrons are bounded to their parent atoms. When temperature increases, these atoms will absorb the energy and they started some vibrations or oscillations. These vibrations or oscillations, they breaks the bond between the two atoms. So in between, we know that in between the two atoms, we have a covalent bond. So that will be broken by these oscillations and it releases the electrons. These released electrons will be excited from valency band to conduction band. So this situation will be increases with increasing of the temperature. It means that more number of electrons will be excited as the temperature increases. So we will see more number of electrons in the conduction band with increasing of the temperature. And we know that the conduction electrons are responsible for electrical and thermal conductivity. So in this way, the semiconductors conductivity is increasing with increasing of the temperature. Next, if we see the extrinsic semiconductor, We know that extrinsic semiconductors are two types, p-type semiconductor and n-type semiconductor. So in p-type semiconductor, when trivalent elements are doped to that, then it will be called as a p-type semiconductor. When fifth group elements are doped to the pure semiconductor, then it will be called as a n-type semiconductors. So here we are going to, first we will discuss on the n-type semiconductors. So in n-type semiconductor, parent majority atoms are parent atoms are silicon atoms only. When pentavalent atoms or impurities are doped to the this material, means a pure semiconductor, then the pentavalent atom is surrounded by 4 silicon atom. For this pentavalent atom, we know that 5 electrons, unpaired electrons, will be available at the outermost orbit. And for silicon atom, we having 4 unpaired electrons. So this atom, pentavalent atom, like phosphorus, is forming 4 covalent bonds with the neighboring atoms. And 1 electron will be available without forming any bond. So this electron will be called as a free electron. So these free electrons are available in the donor energy level. The donor energy level is nothing but it is the nearest energy level to the conduction band. It is the nearest energy level to the conduction band. So all these free electrons will be available in the donor energy level. For a small change in the temperature, these electrons will be excited to the conduction band. So we will see the increment in the conductivity for a small change in the temperature. Similarly, if we go for p-type semiconductors, if trivalent atoms are doped to the pure semiconductor, then it will be called as a p-type semiconductor. According to this diagram, aluminum atom is situated at the center and it is surrounded by 4 silicon atoms. But the aluminum atom is only a third group element, so only 3 unpaired electrons are available. So these 3 unpaired electrons are forming covalent bond with neighboring atom, that is silicon atom. So we are observing 3 covalent bonds with the neighboring atoms. And other side, we have a vacancy is there, or we can say that we have a deficiency of electrons at one position, or we have a vacancy at one position. That deficiency, that vacancy will be called as a hole. So here we have a acceptor energy level. This acceptor energy level very close to the valency band. So according to diagram, you just see here, this is the acceptor energy level and it is very, very close to the valency band. Similarly, for n-type semiconductor, we have a donor energy level and it is very close to the conduction band. So here we have to remember that the donor energy level will be close to the conduction band and acceptor energy level will be close to the valency band. Thank you.